In this recording of the Module 3 lecture, we're going to talk about the measures of position, which are also called order statistics because they are based on the position of the data, the ranked data, that is. And what we did with the median is an example of an order statistic. All right, let's talk about percentiles. Percentile, we call it the kth percentile or p sub k, of a set of observed data ranked in ascending order from smallest to largest, corresponds to a value that indicates that at least kth percent of the observations fall at or below this value, and 100 minus k percent of the values fall above it. In this diagram, I'm showing the diagram of the 1% percentile. So it's the first percentile, the second, the third, all the way to the 97th percentile, the 98th, and the 99th percentile. For example, if the 90th percentile, or p sub 90, means that 90% of the observations are at p90 or below, and 10% are above p90. Perhaps you have heard that a child is at the 90th percentile of weight. That means that the weight of the children, if it is at the 90th percentile, then 95% of the children in the population are at his weight or lower, and only 10% of the children are above his weight. So that's how the percentiles are used often when you visit the physician. All right, here's another example in terms of individual earnings in the U.S. So you can see that the 25th percentiles of earnings is 19,375. That means that 25% of the population or less earns 19,375. The 50th percentile is 42,317. So then you know that 50% of the population earns this amount or less, and the other 50% earns more. The 75th percentile is 85,811. So then you know that 75% of the population earns this much or less, and only 25% of the population earns more than that. And here's the 99th percentile, 506,553. That means that 99% of the population earns this amount or less, and only 1% earn more than that. So probably you have heard of the 1 percentile of the population, or the 1% richest part of the segment of the population. So this gives you an idea of what they are talking about. All right, so how do we find the kth percentile of p sub k? Well, number one, you need to order the data from smallest to largest and assign each of them a rank. Then calculate the rank of the percentile using this formula. So the rank sub c is equal to the kth percentile you're looking for, and you multiply by the number of observations in the sample and divide it by 100. So k is expressed in percentage, like the 90th percentile, then you will replace that with 90. And n, of course, is the number of observations. Now, if to find the p sub k, if the rank k, the rank that you calculated, is not an integer, then pk is a value at the rounded up value of the rank c. If the rank c is an integer, then p sub k is the average of the values at rank c and at rank c plus 1. Okay, let's see how we calculate that with an example. So in this table, we show the profits rounded up to billions of dollars of 12 companies in 2018. They're asking us to find the 90th percentile, and they're asking us to give a brief interpretation of the 90th percentile. All right, so here's the data as is given to us. So the first step is rank the data from smallest to largest and assign them a rank. So you see the lowest profit is that for Unilever, 7. The second one, smallest, is Merck, and then the largest is ExxonMobil, which is over here. So you put the values in order and then you assign a rank to them. Then we calculate the index, or rather the rank for the 90th percentile, and you see that is the 90 times 12, because we have 12 observations, divided by 100. So this is 10.8. This is not an integer. Because it's not an integer, we're going to round that value up to 11 to find the 90th percentile. So then, since it is the rounded up value of the rank is 11, then we look through the ranks and we find the 11th ranked value, which is 17. So this is the P90, or the 90th percentile, is $17 billion. So we can say that about 90% of the companies have profits equal to or less than $17 billion, and about 10% of the companies have profits larger than $17 billion. We're using the word about because we rounded the rank that we calculated to 11. So now we made it into an approximation. But again, this example shows you how we find the percentile. If this rank had been, say, 10 exactly, then we will have taken the average between the 10th and the 11th ranked values. And then we'll take the average of those two, which in this case, both are 17, so the average is 17. But that's the case if we had found a calculated ranked value of that it was exactly equal to 10. All right, now let's talk about quartiles. The quartiles divide the ranked data in 4 equal parts, so 25% segments. So Q1 is called the first quartile, and it corresponds to the 25th percentile. That is that at least 25% of the observations are at or below Q1, and 75% are above it. Q2 is called the second quartile, and it is the median or the 50th percentile. That is that at least 50% of the observations are at or below Q2, and 50% are above it. Q3 is called the third quartile, and it is the 75th percentile, indicating that at least 75% of the observations are at or below Q3, and 25% are above it. All right, the quartiles are percentiles. Then you would think that they will be calculated using the same method that we used to calculate the percentiles, where we calculated the rank C for K equals to 25, 50, and 75. And then we will determine P25, the 25th percentile, which is Q1, the 50th percentile, or P50, which is Q2, and P75, which is Q3, by either rounding up the calculated rank, if it is not an integer, or by taking the average of the rank and the rank plus 1 if it is an integer. Alternatively, we can find the rank C using the formula that we used earlier to determine the median, where K multiplies n plus 1 over 100. So these are two ways of finding percentiles. However, the textbook uses a different approach. You simply divide the rank data into 2 parts to find Q2, then it finds Q1 and Q3 at the midpoints of the lower and upper halves of the rank data, respectively. This is the approach that we will be used for the Wiley Plus assignments. Now, if the data is, if you have an odd number of values, this K times n plus 1 divided by 100 will match this approach. But if they are even, then this approach will not match any of these two. All right, and again, this is not unusual. There are many ways to determine quartiles. And if you use the package R, which is very popular, R offers you 9 different ways to compute percentiles and quartiles. So again, we're going to stick with the method that the book is using for whenever we solve the Wiley Plus assignment. So keep that in mind, please. All right, so once we find the quartiles, then we calculate what is called the interquartile range, which is another measure of dispersion, and it's just the difference between the third quartile and the first quartile. The interquartile range corresponds to the dispersion of the middle 50% of the data, so the dispersion between Q1 and Q3. So keep that in mind because we're going to use that to interpret the interquartile range. Here's an example. So a store manager recorded the values of sales, or rather the value of sales in US dollars for 1 hour. He recorded these amounts right here. So they're asking us to determine what is called the 5-number summary, which is the minimum, the 3 quartiles, and the maximum values of these amounts. And then they're asking us to compute the interquartile range and then interpret the quartiles and the interquartile ranges. Or rather, the interquartile range. All right, so as we stated before, the first thing we do is rank the data from smallest to largest. Then we find the middle value in the data. So this is like finding the median like we did before. So n is 11, so the middle value is 6, so that 5 values are below it and 5 values are above it. So the median is the 9.8, and therefore the second quartile is 9.8. To find the lower quartile, Q1, well, we find the middle value of the lower half of the data, which is 5.9. To find the middle, the third quartile, then we find the middle of the upper half of the data, and that's going to be 11.3. And the interquartile range is just the difference between the third quartile and the first quartile, which is 11.3 minus 5.9, that's 5.4. Also, the minimum is 3.9 and the maximum is 15.5. So the 5-number summary is the minimum 3.9, the first quartile is 5.9, the median is 9.8, or the second quartile, and the third quartile is 11.3. The maximum is 15.5, and the interquartile range is 5.4. So the amount of 25% of the sales are at $5.9 or less, and 75% of the amounts of sales are above $5.9. So the amounts of half of the sales are at $9.58 or less, and 50% of the sales are above $9.8. So the amount of 75% of the sales is $11.3 or less, and 25% of the amounts of the sales are above $11.3. So these are the interpretations of the first quartile, the second quartile, and the third quartile. And then the middle 50% of the sales are between $5.9 and $11.3 for a range of $5.4. So this is the interquartile range. So again, this example shows you how to find the quartiles, the minimum, the maximum, and the interquartile range, and how to interpret these values. In the next section, we'll talk about the box and whiskers plots.